All right, now question number 2 asks you to look at each successive row of elements as larger than the row that preceded it. Let me show you what we're talking about here. Here's the third row of the periodic table, which is bigger than the second row. You can see that's true for any element. Bigger, 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 bigger. Also true for the fourth row, being bigger than the third row. This is the fourth, it's bigger than the third. Bigger, bigger, bigger. You can't make a blanket statement saying fourth is always bigger than third, because here's something in the fourth row which is the same size as something in the third row, or even smaller than something in the third row. But it is true that if we go straight down, that we tend to see this increase in radius. That's what question 2 is talking about. How to explain that? It's simple to do. Each successive row adds a shell! Exclamation point. So if we had something with 2 shells, let's just put nucleus in the middle and 2 shells. 1 shell, 2 shell. 2 shells will be generally bigger than 1 shell. And if we add a third shell, then 1, 2, the third shell will make this a larger radius than just 2 shells. Larger radius. So that's the simple idea here of if you add a shell, the first guess is that it will get bigger, but the shell size is affected by the number of protons. So you need to take both of these into account when you're thinking about the radius of an atom. Simple trends are, go straight down a column, it will get larger. Simple trend going straight across will get smaller. And those are for completely different reasons. This is the shells. This is the protons pulling on the shells. And if you're going on some kind of diagonal, then you can get atoms that are the same size. See this diagonal here, same size.